Hi, I'm Toby Kaplan, and I was lucky to be a classroom teacher and a mathematics coach for more than 30 years. Now I get to work with Symphony Math. We're going to look at a routine that could take 15 or 20 minutes of your class time, and it will work with your whole class, with a small group, one-on-one, and yes, it will even work remotely. The focus of today's lesson is going to be stage 13.1 to stage 13.3, which is multiplication. Now, up to now, students have been skip counting, and they've been adding the same number to itself, and this is one of the first times they see multiplication with all the times and the equal signs in there. And this is their introduction to the multiplicative relationship. This is a critical relationship, and it forms the basis of our place value system for whole numbers and decimal numbers. The big idea here is repeated equal groupings, and you can learn more about that in the stage overview in the Symphony Math support page, stage 13. I'm going to show you some tasks that you'll be able to do with your class, and they involve my modeling and talking and asking questions that get students to reflect, and then having the students to do some work on their own. The materials you can use today will be the dot cards and the number cards. And that's because we're going to use the familiar Symphony Math materials, which will bridge from additive thinking to multiplicative thinking. Sets is a great way to introduce students to groups of and repeated equal groupings. You can feel free to use any kind of chips or teddy bears or anything that students can count. Here we go. Well, here's a problem that we need to make sense of. I see a 10 and a 5 dot card, so I know that makes 15, and that's the total amount we have. And we see, well, 15 doesn't equal 5, but what it says here is that we need equal groups. And I'm to understand that there will be 5 in each group. So the question is, how many groups of 5 will make 15? I'm going to use some placeholders here. These are my groups. Let me put some empty cards. Over here in my hand, I have 15, that's the total amount. I have 15 discs. And I know I need to put 5 in each group. So I'm going to start with that. So we've got 1, 2, 3, 4, 5. There's one group of 5. I still have discs left over. All right, let's start again. Here's a second group, and I think I have enough to go 6, 7, 8, 9, 10. Well, that's two groups of 5. I've got some discs left over. So let's try a third group. We're up to 10, 11, 12, 13, 14, 15. Okay, I want to make sure I know I have 5, 10, 15 discs all together here, and I know I needed to make 15 altogether. So it seems that 15 is the same as 1, 2, 3 groups of 5. What do you notice? What do you wonder about? This is a chance for students to stop and reflect. Let them think quietly to themselves. After a while, they can communicate their ideas, and we don't judge them, we're not going to correct them. Now, some students might say something like, well, I saw there were 2 5 dot cards. I mean, that's fine. Either allow the conversation to continue, or you can nudge them. You might say, yes, there were 2 5 dot cards. I wonder what the 2 5s were. Were they the same in the 15 as they were in the number of dots per group? Where did we get the 15? How did we know how many groups to make? Just let the conversation flow, and you'll see what students understand. Let's make a number sentence that matches this model. Okay, we have 15 altogether. So let me take my 10 and 5 card to make 15. Well, now look at this. The 15 comes before the equal sign. But did that bother us? No, we still needed to figure out how many groups of 5 we needed to get to the 15. We didn't know at first. We knew that we needed some number of groups, but we knew that we were going to say times 5 because we understood that there's 5 in each group. Well, we counted by 5s, 5, 10, 15, and we saw that we needed 1, 2, 3 groups of 5 to make 15, or as a mathematician would say it, 15 equals 3 times 5. Again, ask students, what do you notice? What do you wonder about? Now, students might mention some things like skip counting. They might have said that they added the numbers. They may make some comments about the whole, the 15 being before the equal sign. And then you can ask them some questions. Well, would it be different if that 15 came at the end of the number sentence? How would you go about solving it then? How did the dot cards help you solve this problem? Did you know at first how many groups you would need, or did you know how many would be in each group? Don't spend a lot of time on what the two factors mean, the first factor being how many groups, the second factor being how many in each group. Just say these words, and then the meaning will evolve over time as you continue with your work on multiplication. We can do a second task together. The second task is a story problem. We know sometimes students get upset when they see a story problem, but we see it as an opportunity. Context is very important when learning mathematics, and by giving a multiplication sentence a story to anchor it, it gives students more meaning into what the numbers mean that they put together in order to multiply them to find an answer. Okay, let's do this task. Here we have a story problem. We can see Jamila has 12 pieces of candy. She wants to put the candy, the same amount of candies, into 4 bags to give to her friends. How many candies does she put into each bag? Okay, let's see if we understand this. We see that Jamila has 4 bags of candies. Well, let's use this as a placeholder. 1, 2, these will be our bags of candy. Here are 4 bags of candy. We know altogether Jamila has 12 candies because it says 4 bags of candies, 1, 2, 3, 4, and altogether she has 12. Okay, so here I've got 12 chips. I'm not sure how much to put in each bag, so I'm going to do it this way. I'm going to put the same amount in each bag until I hit 12. I'm going to start with 1 in each bag. So 1, 2, 3, 4, I got a lot left, 5, 6, 7, 8, 9, 10, 11, 12. Well, I've used up all the 12 candies. Here's my 12. I have 4 bags, 1, 2, 3, 4. And do I have the same amount in each bag? Well, 3, 6, 9, 12. Yes, I do. Okay, what do you notice? What do you wonder about? Again, we're asking students to stop and reflect. And no matter what they say, it's what they notice, so they can't be wrong, and we want to provide a safe space for that. We don't correct them. Let them talk, and if they notice something that's not mathematical, like, well, there were a lot of blue discs, you can say, oh, yes, there were. Well, how did we know how many discs or how many blue chips to count in the first place? Where did that come from, since there were 12? And how many of those blue discs were in each bag of candy? All right, after they've had a chance to talk and say what their ideas are, here's the next thing. Let's make a number sentence that matches this model. Okay, well, I knew that I had 4 bags of candy. We knew that. And I also knew that I was multiplying that times some number in each group, but at the time, I didn't know how many I was going to put in each bag. But I did know that altogether, the whole amount we had was the 12 candies. So we knew that 4 bags times some number of candies in each bag would give us 12. Well, we counted 3, 6, 9, 12, and we saw that 4 times 3, or 3 and 3 and 3 and 3, 4 groups of 3 make 12. Mathematicians would say 4 times 3 equals 12. What do you notice? What do you wonder about? Now, as students think and start to share their ideas with each other, you might hear some words like divide. They divided up the candies. We might hear some words like they did some skip counting. Maybe they added. It's great if these ideas get out on the table. You're not going to necessarily wrap all of that up, but these are important factors into what makes multiplication multiplication, because the connection between addition and subtraction and multiplication and division is a vital relationship in this work in math. After the students have had a chance to do some talking and sharing of their ideas, you give them the message that now they're ready to do some tasks on their own. And you can find more tasks if you go to stage 13 through 1, 13 through 3 in the guided practice on your Symphony Math support page. And you can also go to the demo in the student page and pull out 13.1 to 13.3, where you will see many different examples of tasks that you can ask your students to work on, and you can project these onto your smartboard. Have the students make models, have them talk, have them share their ideas, and you can listen to what they're saying. After a while, when they are done making models and communicating with each other, don't worry if they make mistakes. They often correct each other, and they often notice things and say things before we have to tell them. When they're done, you can say, "We worked on multiplication problems today. I heard some of you talk about dividing, adding, skip counting, as well as multiplying. Well, there is a mathematical relationship amongst all these operations. This is an important discovery you've made." As students go back onto the Symphony Math program, stage 13, you can see how they're doing by looking at your dashboard. If you go into individual students' use and progress page, you see red, yellow, and green informative icons. When you press on an icon, it lets you know the kinds of problems students are able to handle, the ones that give them some hesitancy, and the ones that are stumping them. If you see a lot of red, it's a signal to you to continue some offline work with your student and have them make models and talk, and above all, listen to your students. Have fun.